Welcome back. If you've spent any time at all in tech, you know it's a world just drowning in acronyms. So today, we're tackling one that's having a really serious identity crisis: IDR. Let's just dive right in, because this simple three-letter term means wildly different things depending on who you ask. So, yeah, what is IDR? Seems like a pretty straightforward question, right? But the answer is anything but. Seriously, depending on whether you're talking to a security analyst, a cloud engineer, or an AI developer, you're going to get a completely different answer. Okay, first step, in the world of cybersecurity operations, IDR stands for Incident Detection and Response. Just think of it as the security team's mission control. They're sifting through these absolute mountains of log files and network traffic, looking for that one tiny anomaly, that digital needle in a haystack that signals an attack. And then they have to act on it, fast. But wait, it's not that simple. For another whole group of security pros, IDR means Identity Detection and Response. Now, this is hyper-focused. We're not talking about broad incidents anymore, but on the single most targeted asset in pretty much every modern attack: your identity. It's all about protecting usernames, passwords, and permissions from getting stolen and misused. And just to make things really confusing, if you step outside of the security bubble, IDR becomes intelligent document recognition. This is all about using AI to automatically read, understand, and pull key info from documents. It's an incredibly powerful automation tool that has absolutely nothing to do with security incidents or identities. So yeah, we have a genuine identity crisis on our hands. One acronym, three totally distinct, powerful technologies. But here's the cool part. Understanding each one gives us a fantastic window into the modern tech landscape. So let's start by focusing on that first one: incident detection and response. And to really get a handle on what incident detection and response looks like in the real world, we're going to look at a great example: the IDR service from Amazon Web Services. This is going to show us exactly how all that theory gets put into action. Okay, so this map here lays out the whole flow. Over on the left, you've got the customer's cloud environment. When a critical service, say a database or a load balancer, has a problem, it triggers an alarm in CloudWatch. That alarm then gets funneled through Amazon EventBridge directly to the AWS IDR tool on the right. It's basically a direct line from problem to response. But hey, setting this up isn't as simple as just flipping a switch. This timeline shows it's a really detailed multi-week process. It's a true partnership. In phase one, AWS gets to know your systems. And in phase two, you're working together for weeks to define exactly which alarms matter and how to get them ingested. It's that deep collaboration that makes the response so effective. Now, a key part of that setup is creating what's called a runbook. The best way to think of it is like an emergency room protocol, but for your cloud. It's a pre-approved set of instructions that tells the AWS engineers exactly what to do, who to call, and what to say the second an alarm goes off. This just eliminates any hesitation when you're in a crisis. This diagram shows us the process right in the heat of the moment. It all kicks off on the left when an alarm fires. Instantly, an AWS service creates a support case and pages an engineer, and all of this happens within 5 minutes. That engineer immediately grabs the runbook we just talked about to understand the customer's specific needs. From there, they engage the right teams and follow those pre-approved steps to mitigate the problem. It's a machine built for speed and precision. Okay, so that's the incident response version of IDR, but remember our little identity crisis? That second definition, identity detection and response, actually fits into a whole family of security acronyms. So let's zoom out and see how this all fits into a complete defense strategy. This table breaks it all down pretty nicely. You have EDR, which is all about your devices. It protects your laptops and servers. Then you have the other IDR, the identity one, which is all about the people, protecting user accounts. And then there's XDR, or Extended Detection and Response. That's the big one. It's all about the logs, pulling data from everything: endpoints, identities, networks, to give you one single, unified view of a threat. So we've talked a lot about these powerful automated tools. But all three types of IDR rely on one absolutely critical component that you just can't automate: human intelligence. In an age of AI, our most human skills are actually becoming our most valuable assets. I just love this quote from Einstein because it perfectly captures the challenge we're facing right now. We have these incredible tools that can resolve problems in seconds, but all that power is completely wasted or even dangerous if we don't spend that crucial time up front defining the right problem to solve in the first place. And at the end of the day, it's skills like these that make tools like IDR actually work. It's all about asking the right questions of your data, assessing the information you get back with a critical eye, and really understanding the context. You can't just blindly trust the output, no matter how confident and authoritative it sounds. And look, this isn't just some academic idea. This is a real concern from someone on the front lines, right there in the cybersecurity community. The pros doing this work every single day are realizing that these so-called soft skills, critical thinking, clear communication, they're becoming the absolute bedrock of their profession. Which really brings us to our final thought. As our technology gets smarter and smarter, capable of detecting and responding in milliseconds, maybe the most important security asset we have isn't the tool itself, but our uniquely human ability to think critically about the problem we're even asking it to solve. What do you think?